in this lesson we want to start taking a look at what is experimental probability. Okay? Now let's look back at what we've been doing. We've been doing the chance of flipping a head on a coin, simple probabilities, chance of rolling a 3 on a die, and then we took a look at compound probabilities, taking individual events and joining them together with multiply. What we have to understand is all of that stuff we've been doing up until this point is definition-wise called theoretical probability. It's probabilities, fractions, percents, decimals, that are based on what should happen. So if I take a look at a regular sided die, chance of a 1, 2, etc., we all know that out of each one there's 6 total sides, and we know that there's 1, 1. So in theory I should be 1 out of every 6 times, 1 out of every 6, 1 out of every 6, and so on. Now we know it should be this way, but it doesn't always happen that way. Just like when we predicted outcomes. Not all the time does it exactly end up being that. There are times though when you'll get a set of data, or a picture, or a chart, and it'll say, what's the experimental probability? What experimental is, the difference between the two, they're both a number that tells you the chance of something happening. But what experimental is based on, not what should happen, not how many total sides it has, and not how many of the events you have, but it actually is based on what actually does happen. So for instance, let's make a quick chart. And you will see charts that look like this. Same idea, I'm rolling one die. 1, 2, 3, 4, 5, 6. And what this means is, nobody looked at the chance ahead of time, they just took an object and started using it. So they kept a tally chart. So and your tally chart might look like this. Now we know, because it's a die, it should be roughly equal. All of them should be 1 out of 6. If I look at these numbers, they're not equal. Now, if you think about it, when you roll a die a bunch of times, it doesn't always have to be balanced out. Sometimes it's heavier in one number than another. But here becomes the bottom line. You're given a chart like this, and the question says, what's the experimental probability of this? Well, you don't go based on what you think should have happened, you go based on what did happen. And we'll understand, or we'll talk more about this later, of why we're doing this. Well, here it goes. So let's say the question is this. Probability of a 3. Experimental probability is roughly the same construction. The bottom number is the total experiments or trials that you did. The top is how many of the event that you had. So it's basically the same concept, but this total number is the total number of trials or experiments. That's why it's called experimental probability, just like in science class when you run experiments. Running one experiment isn't good enough. You often have to run trials, or many of them. So let's take a look. Okay, my video got cut short, so I have to pick up again. Here is my chart of data. I want to know, what is the probability of 3? Now again, this is experimental, so I'm taking a look at total trials. If I would add all these up, 5, 5, 5, 5, 5, another 5, and another 5, hopefully if I added right, it gives me a total of 35 events or experiments or number of times I did it. Excuse me, probability of a 3. How many 3s did I get? 5, 6, 7. This becomes my experimental probability. It's not what should have happened, it's what actually did happen. Take your chart with the actual numbers on it, take these numbers and make an actual experimental probability. Now I could reduce this, I could say 7 over 35 is the same as 1 over 5. I could turn it into a percent, which would be 20%. Let's look at one more. Probability of a 6. Not what it should be, what it actually recorded to be. 5, 10, 15. I had 15 6s. What is my total number of trials? If I add all these up again, I still have 35. And I could reduce this. This becomes 3 out of 7. I could use a calculator to get my percentage. Again, I'm not worried about that now, but you could do that. So just understand, experimental probability is taking the actual experimental results, using your chart, counting up the numbers, and writing your fraction from here.